Hi, my name is Sunil Grover, Principal Solutions Architect for SAS, and today I'll be sharing a demonstration using visual statistics to showcase clustering analysis for a variety of predictive marketing applications. With that said, let's jump into it. In this demonstration, we're going to utilize clustering analysis within visual statistics to perform data-driven segmentation. In this use case, we'll use clickstream data, and let's say we want to understand a little more about the anonymous visitors that come to our website. In this case, you may have access to third-party data that you're able to append to your clickstream information based on the geolocation of the visitor, or perhaps you're extracting information from your digital data management platform. Whatever the case is, in my exploration, I'm going to try to understand what is the age levels, the education levels, the employment levels, and the level of affluence of the different type of visitors to our site. And so I'm going to drag those 4 attributes and drop it into my analysis. And visual statistics runs a K-means clustering approach and very quickly crunches through the data. So let's take an actual look now at how we can assess what we've just done. One of my favorite visualizations in visual statistics is this parallel coordinates plot. And let me expand it for you. So what we're looking at are 5 cluster IDs that were generated as the output of the analysis on the left vertical line. And across the top horizontal line, we're looking at those 4 attributes for age, education, employment, and median income. So if I want to start exploring each of these segments, all I have to do is come over here and click on an actual cluster ID, and it will isolate that segment. So now I can interpret and hopefully make an extrapolation of what we're looking at. So if I look here at cluster 4 or segment 4, we can see that when it comes to age, they're somewhere in the middle of the age spectrum between 25 and 65, probably 30-somethings and 40-somethings. They're highly educated, and it looks like when it comes to employment level, they're peaking in their careers. And thus, as we would expect, they're also doing very well when it comes to household median income. So this is an affluent, middle-aged, career successful segment. I can now click on the next segment, and we see a very different story. This segment, much older in age, 50s and 60s. Their education level is moderate to low. Their employment level is essentially indicating to me most of them don't have a job. And their income, as we might expect, is quite low. My interpretation as an analyst, this is a retired segment for the most part. They're not in the workforce anymore. And the same goes for the next segment we might look at, and this is the last example, where we're looking at a very young segment. They're in their 20s and 30s. Their education level is moderate to high, and their employment and income seem to correlate with those findings, indicating to me these are aspiring millennials. So 3 very different segments that I was able to identify very quickly using the clustering analysis here in visual statistics. For those of you that would like to go farther in your analysis, we can actually minimize that parallel coordinates plot and move over to the cluster matrix. This will give us an expanded view through visualization to assess how much overlap we have within our different clusters or segments by the different attributes that we fold into the analysis. Some options you can take advantage of. You can expand the visualization. We also can plot based on the attributes we showed, in this case age or education level, and plot it by the cluster or segment IDs. Is there enough differentiation there or not to satisfy me as an analyst? With those different assessment tools at our fingertips, we also can come over to our property settings and make an assessment if we want to keep the number of clusters that visual statistics ran in this first pass of the analysis, or if we want to adjust that and maybe try to optimize using 6 or 7 or 4 or 3 clusters. Other options also available here for one to consider, but let's transition to how we would actually take action on the results of this analysis. By clicking on this drop-down arrow, I have 2 options I want to go over. First and foremost, I'd like to go over the idea of exporting score code. And what this will do is inform visual statistics to auto-generate the score code of this analysis. Now, this score code can be leveraged in any sort of marketing workflow to operationalize or productionalize on. An example of this would be, say, website personalization. When a future visitor comes to our website, we would like to run this score code in real time to allocate that visitor to a segment, thus driving a unique personalization that will be most relevant for that segment. Other than exporting the score code, we can also derive a cluster ID variable. And what this will do is, by clicking on this particular button, I can actually tag every single visitor in my data set or in my clickstream snapshot that I'm analyzing and assign them to one of these 5 different segment IDs that I've concluded on in this analysis. And so I can come in here, and instead of calling it cluster ID, I'm going to call it segment ID. And when I click OK, I can add a new attribute to my data set. And you'll see here that segment ID has been added, and I can now use this in subsequent analysis, say in regression or decision tree analysis, where I can actually build models by segment. And this is very valuable because I've now just enriched my existing data set with new information. With that said, this demonstration has covered an algorithmic approach to data-driven segmentation, and we hope that you found it compelling. So that was a demonstration of visual statistics for predictive marketing applications using clustering analysis. We greatly appreciate your time today. We hope you enjoyed it.